Good. So back again for a morning session. It was unexpected, but a little bit of an extra session. We are scheduling it for you all today. Supposed to be done in the evening hours, but packed with the 25 batch sending off because ekolange papers, seminar series, and everything at the පොඩ්ඩක් ඒගොල්ලන් එක ගොඩක් පැක් වෙලා තිනවා. But hopefully things get soon good. So we are starting off with communication for today. Okay, from our networking chapter. So in all our centers, අපි networking chapter එකේ communication part එක අපි අද පටන් ගමු. Okay, this is for the online and physical වල Eduzone and team Comrade students ලට දෙන්නට එකතු කරලා තමයි we are doing this communication part. Right. So let's get started. Okay. In from page number 75. So we are going to be talking about all different types of signals and its propagation. How do they differ? What are the technologies under signals and generally, okay, the complete sections too. So this will take around another two to 3 weeks in terms of completing. But mom make a pulu atarang ikmanta එක complete කරලා දෙන්න. Right, so let's get started off, okay, with the section. So number one, okay, we will be going through with the signals. So let's get into page number 75. Right. So let's get into page number 75. Okay, in 75, we're going to talk about two forms of signals. Now, electrical signals, we do have two types. One is the analog form, and the other one is digital form. So in simple, if I tell about in these two differences, okay, a type of a signal which uses variable state, a type of a signal which uses a discrete state. We take the analog signal, okay, and use an ADC converter. What is ADC converter? Analog to digital converter, okay, and process digital signal. This analog to digital is something like this. We take the, we'll take the wheat, or else, yeah, okay, we can take another can we process karla, we can get, yeah, we can get wheat again, okay, wheat and we can take any of raw materials. I'm not getting it, okay, yeah, green hari cereal, green hari munahari again. Cereal gain nathang wheat hari again. Meava process karama we get flour. FOLUR, right? Flour. Okay, mavu. මෙන්න මේක තමයි basic process එක. Okay, where we take the analog signal, use a kind of an device called as ADC, we'll talk about it later, analog to digital converter, and then you will get the digital signal. Now what is the difference between the analog signal and digital signal in general, where they are used, how they are used? Okay, analog signal consumes more power, okay, more power. Your electricity is used to transmit analog signal, but computers, okay, are made with cost efficient. Now මෙතන power efficiency එක හදන්න, power consumption එක low කරන්න, they introduce something called as, okay, ICs, integrated circuits. Now these integrated circuits are digital circuits which uses digital current. So digital current is moreover low power consumption, okay, low power consumption, but analog is about high power consumption. Another example of analog and digital we can take, okay, your voice is analog, your recorded voice is digital, okay, your heartbeat is analog because it can go in any range you wanted, high voltage and low voltage. These are a continuous signal frame, a discrete signal frame. So analog is basically continuous. So a positive या not negative it can go all the way up, can come all the way down. But in digital, it is discrete. So there are devices which uses digital signal, especially for power, low power consumption. There are different type of signals which use high power consumption, especially for analog. So analog and digital like overall difference make the way how electricity are being transmitted. You transmit as it is analog. You convert and transmit it, that is digital. So electrical transmission we have two types. Transmission of signal transmission we have two types, analog versus digital. Sounds clear? Right. So using analog, what are the devices we do have? Do we have different devices? Do you know other? Yes, there are different types of analog TVs are there too. I'll be sharing you all an image. We all can take a photo of this image and then you all can paste it. You all can also paste it. එක paste කරලා තියාගන්න. මෙන්න මේ වගේ image කෝලන්ට යවන්න with all the analog මෙතනට ඕන ටික. So we have the analog TV, analog computers, see, analog computer, analog TV, analog speakers, analog recording. These are all used as what? Continuous form of electricity, high power consumption. Okay, and make devices avilla monada kiyanda expensive also more over time. Okay, then digital circuits are way more cheaper, but this uses continuous form of current. මෙහෙම තමයි තියෙන්නේ. Okay, ඒකේ current එකක් ඇවිල්ලා නිකන් උඩත් යනවා පල්ලෙහාත් යනවා. See, can go in negative range, positive range, in any spectrum it can reach. මේකට කියනවා අපි analog transmission. Analog transmission. Sounds okay? I'll be sharing this image after the class in our WhatsApp groups and also in the LMS. ඔයාලට මේකේ photo එකක් අරගෙන you all can paste these images. Okay, so let's get into the next one. Questions. We didn't give marks this time, Raja. Okay, local marks at Dunnapi, we just corrected only. Good. Then we have on the other form digital. So let's read this analog. Analog signal is an any continuous signal which is type varying of the signal is represented in some other variation quantities. The following are examples of analog. So time varying, a continuous signal like a analog. On the other hand, we have digital again. These are the normal computers and laptops we all use. These are created using digital circuits, cheaper device, cheap, low power consumption, low power, and also faster, right? Good. This is a signal that used to be represented as a sequence of discrete values on and off. So in these devices, we don't have a continuous form. Instead, we have only high and low voltage. On no off. The current will be either on or the current will be either off. So these are the images. Make it image cut karla paste karega. Great. Okay. Next one, let's go through with a comparison chart, okay, of analog versus digital. So analog wala you have basically a continuous form of signal spectrum, but digital wala you have, okay, discrete sectors. This is what we have it as analog versus digital. Like, okay, next we are going on with the differences between analog signal versus digital signal. Okay, we know that analog signal like signal like it uses a continuous form of signal range. Good, we'll write a difference. Signal, okay, analog is a continuous signal which represents the physical measurement. But on the other hand, digital signals are discrete time signal generated using a modulator. Analog, you got an example. Your human voice is analog. Electricity is analog, right? Cellular 4G and 5G is also analog. On digital, we have a computer is digital, a mobile is digital, television is digital, okay, smart watches are digital, way more cheaper devices. Bandwidth के लिए कहना the amount of data it can process. Okay, bandwidth के लिए कहना amount of data that it can process. एक है हमारे bandwidth का के लिए कहना, right? So let's see the bandwidth side also. As processing can be done at the moment, you can process at the moment, it consumes less bandwidth. So since you can do the processing at the same time, you don't need to do any changes, it can, it has only less bandwidth. Analog. And in digital, there is no guarantee that digital signal can be done in real time. You need to do the processing. Therefore, it may consume high bandwidth, more bandwidth. Good. Right. Amount of data it consumes. Okay. Consumption of data kila kanda below. Consumption of signal. So it takes less amount of signal to transmit. It takes high amount of signal to transmit. Here less and here high. Sounds okay? Done and dusted. Nice. Okay, so let me also show you an example of this analog to digital converter here. So we have a 3-bit ADC converter. Okay, 3-bit ADC converter actually ADC meaning analog to digital converter එකක්. Okay, see this is the analog signal that we are getting as the current. So it's a direct current input එකක්. Okay, so it comes in there. Okay, and then this converter converts your signal in this way. See, high voltage, low voltage. See, it's a 3-bit converter. It converts the current. These are all digital currents, discrete current. Okay, make it. So in this way, where we have the analog signal, me and analog signal, like I can increase the frequency, I can decrease the frequency. Okay, so frequency gana I can also reduce it or increase it. This is 2 seconds, what of 5 seconds dala. Okay, good. Nice. Okay, frequency gana වැඩි කරා. ඊට පස්සේ you check this out. මේ බලන්න. Okay, you will be able to see the output. See, this way you will be able to see the output. Make it a digital to analog converter. Nice. Now here we have some properties. We will be talking one by one. What are these properties of? Okay. What are these properties of this signal? Of a signal की properties ටිකක් තියෙනවා. Completed. Bandwidth කියලා කියන්නේ the amount of data taken to send. So bandwidth refers to the consumption of signal. So less bandwidth is good, but the problem is digital signal like a bit less bandwidth යවන්න බෑ because you have to convert it. So analog gilla, you have both the ups and downs. The analog can be easily sent quickly. So since it consumes less bandwidth, podi bandwidth at තිබ්බත් you can send it. You can signal like a minimal කොච්චර තිබ්බත් you can send it. But then in digital you can't do. You have to have that set of okay required bandwidth is needed. Okay, amount of signal is needed to send. You can යවන්න So both has plus and minus, and we use these in different places. Perfect. Let's go and learn one by one the differences, okay, of the signal properties. Number one, we do have amplitude. Amplitude refers to as the maximum displacement. We call it as the amplitude. Frequency is the number of cycles. අපි එක ලස්සනට example එකක් මම ඔයාලට කියලා දෙන්නම්. We call it as the frequency. Okay, then we have the phase, the change in the signal, we call it as the phase. And then we have the wavelength. Okay, the total number of cycles. अभी मैं आपको explain करना ना in detail. So these are a couple of frequencies. So what are these amplitude? What is the key frequency? What is phase? I'll explain it you all in detail. But me technical एक बार आगा the maximum displacement, okay, of a participating taking part in a wave motion is known as amplitude. Think about an F1 racetrack, okay, where you have so much of Formula Vehicle 1 cars, and okay, make car okay, from 0 to 100, okay, kilometers per second, okay, it takes only 5 seconds. That is the what we call it as the amplitude. Top speed amplitude the maximum displacement, we call it as the amplitude. Frequency के लिए क्या ने lap time में का एक lap पे का complete करना how many seconds it took एक ना frequency. You increase the speed, automatically frequency will increase. You decrease the speed, automatically frequency will decrease. Frequency is the number of cycles, the lap time. Okay, मेरे ना lap time में अकेला. Phase के लिए क्या ने मोनाहर change in time मुनामा. Change in time. Natam body accident kakunot we call it as a phase. Accident kakunot. Accident kakunot. It's known as a phase. Any change in the signal frame we call it as a phase. Right? The distance between start and finish. Start and finish के distance है. इकड़ की what is it? Wavelength. See, easily I made it because we all are not technical students. Okay, apita will lecture technical stuff. Dila explain karle anegata vada. This way, I think I made it way more easy for you all to understand. Number one, what is it? We'll think about an F1 racetrack. Okay, racetrack के करदान वाने F1 formula गयाने right a racetrack के and with that only I'm explaining it, so I'm relating that to our signal spectrum. In this racetrack a vehicle's okay, top speed देखना पिकाना पलंग amplitude, the highest displacement is amplitude. Okay, so you are mapping the vehicle performance in a graph, right? In that, a time taken to complete the lap, we call it as the frequency. You can increase the frequency, meaning speed increases. You can reduce the frequency by reducing the speed. So speed is refers to as what? The frequency. If any change occurs, okay, monahari ka accident kare monahari okay, drop पे का brakes apply करत, we call it as phase. You apply brake, that is known as phase. Okay, nice. And then the distance from the starting to the finishing, we call it as the wavelength. These are like relatable examples. It was one technical explain karana when you go in detail one by one. Okay, signal transmission. Okay, in telecommunication, transmission is a process of sending and propagating analog or digital signal over physical point-to-point or point-to-multipoint medium via wired or wireless technology. What is point-to-point? From one end to another end, we call it as point-to-point. One from end to another end and one end to multiple ends, we call it as point-to-multipoint. Mehema connect to this is we call it as point to multi-point. Multiple are connected point to point from one tower to another tower. Point to point. When two towers are connected, think about these are like towers. Cellular towers which transmit signal point to point from one end to another end. Okay, ඔයාලන්ට ඕන විදිහට ලියා ගන්න, but interestingly I explain it to you all. ඊට පස්සේ තව technical example yeah. Okay, done. Happy? Nice. So let's go through one by one. What are these carrier signals? What is these modulated signals? And also, okay, of the modulation part. Now, in transmission, we have something called as a carrier signal. What is a carrier signal? A signal that carries information. So, what is basically a carrier signal? A signal that carries information. What are the normally a carrier signal? Good. A signal like a normally can be in form of analog or digital. It doesn't matter. Okay. So in this way, you might have it. This is a carrier signal. Good. So it can be in digital form or analog form. A signal that carries the information. But this signal can get altered easily. So we have to perform modulation. We have to do alteration for this. So modulation is done to alter the signal. Process variation in one or more properties of a periodic waveform. So alteration in signal is known as modulation. Why do we do modulation? So we can protect the signal. Okay, now phone එකක් අරගෙන අපි phone එකට ඇයි cover එකක් දාන්නේ? ඒ phone එකට ඇයි අපි tempered එකක් ගහන්නේ? So that your mobile phone will get protected. Similarly, to protect the signal, okay, we have the modulated signal. Like an iPhone, okay, that is a carrier signal ng iPhone case එකක්. That is modulation, so that your signal will get protected. Modulated signal ke example you can say this ADC, analog to digital converter, who converts the analog signal to digital form. That's an example of how modulation works. Good. So let's see one by one. Okay, මේක කොහොමද it happens in there. So analog to digital converter perform this type of function to create series of discrete values out of the given analog signal. So we have analog to digital converter එකක්. Okay, good. It goes through three steps. Number one, it goes through called as the unsimplified signal, like so we have that the signal form here like this. Okay, we call it as unfiltered analog signal. Unfiltered analog signals, where is this we do have, and it goes through a process called as sampling, where it converts into regular intervals. Unfiltered signals will be gone through a step called as what? Sampling. So a sampling making, what you see it is, you see those signals convert into discrete intervals like this. Like this. You see that signal gets into discrete intervals. Something like this. This is we call it as sampling. Perfect. ඊට පස්සේ you have this sample signal, you make it into what? Quantize කරනවා. Quantize කියලා කියන්නේ you get it into nearest discrete values. So once you know that, you understand, okay, this is a high voltage, this is zero in the sense you can ignore it. Again, high voltage, it is zero in the sense you can ignore it. And you quantize it. Quantizing. In sampling, you get the nearest, sorry, in sampling, you get into regular intervals. And in quantizing, you get into the nearest discrete value. Discrete value. And then in encoding, you have series of 1 and zeros. This is we call it as encoding. Make it my computer understandable language. So your analog signal will go through these three steps to get into digital signals. Make it digital signals කියලා and මෙයාට කියනවා digital bits කියලා. So check this out. Sampling, measure the analog signal at regular intervals. Okay, round the sample values to nearest discrete values as high voltage and low. If it goes beyond a certain value, zero. Nothing one. Then encoding, okay, assign unique binary code for each intervals. To do this, we have pulse code modulation. तमा use करने. So pulse code modulation perform this analog to digital conversion. Good. So ADC you can convert it. Analog to digital pulse code modulation does this conversion. Who does this conversion? Pulse code modulation. The device is ADC, analog to digital converter. That's the device. Okay. Pulse code modulation is the technique, and ADC is the device. ADC is the device, and this is the technique. Can we copy down this? Whatever the important sections. So summary, what did you learn? You're learning about a signal that has only okay, continuous form. We call it as analog, which has a discrete form, digital. Analog consume high power, digital consume less power. Analog is expensive, digital is cheap. Digital is bit expensive, analog is cheaper, moreover. Okay, analog consume less bandwidth because it can send data quickly, but digital consume high bandwidth in there. Okay, and overall, okay, analog digital theater, you can make different varieties of devices. One of the example is when you send your normal signal, we call it as a carrier signal, the signal that has information. But you modulate this signal by altering the signal properties. Alteration in signal properties, we call it as what? Modulation. Why do we perform modulation? So your signal will get stronger, okay, and then your signal will not get interference, external interference, nothing, interference in a okay, alteration in a signal well, you can cover long distance. When you do modulations, you can cover long distance, you know. So example, ADC, analog to digital converter. So who converts analog to digital, analog signal to digital? How it happens? Through three steps: sampling, quantizing, encoding. All these are alteration to the signal property, so we call it as modulation. So who does this ADC modulation? Pulse code modulation does it. And what is the device? ADC, analog to digital converter. Sounds okay? Understood? All clear? Okay, good. So let's see also other type of modulations too. We can do changes for the amplitude, frequency, and phase. We can also perform in digital modulation, amplitude shifting key, phase shifting key, and frequency shifting key. This is analog modulation. When you do modulation, you can cover longer distance, the signal becomes stronger, less external interference in there. So in analog modulation, what you do, it's like increasing, okay, the like volume. For an example, analog I can say amplitude modulation I can say. And amplitude, what is it? The top speed eva gamer. Okay, in a radio you do have the volume. A volume make a increase karne ka I can say it as analog modulation. Okay, so we get it and we convert this analog modulation. We call it as analog modulation in general. Okay, you increase what? The volume. Once you increase the volume, you will be able to do analog modulation. So let's see how it happens in analog waveform. So think about a normal waveform is in this way. Okay, when you perform analog modulation, this is the normal waveform. We call it as the carrier signal. Once you perform modulation, it will increase the amplitude part. You can a spectrum we are increasing the amplitude in it. Okay, frequency is like the quality. Okay, you can increase and decrease the frequency of the signal too. So basically frequency refers to the quality of the signal or else the cycle. So in an example of our uh, if one track ki example like a keyword. Okay, so what is it? The frequency, the laps, you increase the number of laps. That's what all about frequency. So if this is the spectrum, you increase it as much as possible. Frequency के वैडी the amount of data which will be transmitted is higher, so it get compressed. Okay, it gets compressed. So from one frequency to another frequency like this. So if the signal spectrum maker, if I put it in uh, the frequency modulation, it will be like this. You will have a compressed signal form like this. Maybe a compressed signal form yakavilla. Then you will have a small relax. Then again there will be a compressed signal form like this. Okay, hold on. Let me get an image for you all quickly. Maybe theater like this. Now you can have this diagram itself. Frequency modulation. It is like increasing the amount of data you do. Phase modulation के लिए क्या alteration in the signal. It cannot be phase modulation kela. For an example, if you are having a song or else any kind of a song you are playing, you can alter the treble, bass, annevagi maru karnone. Annevagi cannot be monada. Okay, phase modulation. You alter the existing signal. Make it cannot be fall phase modulation. See, phase se kak alter kara. Tava phase se kak alter kara. Any alteration that you perform in the signal, we call it as phase modulation. It's like you changing the gears. Okay. Now, what is a phase ke like an example? In our example, like mangola phase se represent kara brake. You apply the brake. So you're suddenly going on a normal speed and you apply the brakes. एक phase alteration. Now, in real examples, you increase the volume, we call it as amplitude modulation. If you increase the quality, we call it as frequency modulation. You alter the bass, okay, natang tune karano, natang if you take it on, you are increasing any kind of tune. Equalizer hadano, bass, treble, okay, natang we can see what else. Audio bass, treble, okay, what else we have? Balance, kilikatino, mid kilikatino, so no balance kilikatino, mid ka kilatino. So me ukkum alter karne ka tamai face modulation ne ki All right, okay. So let's get in the last one. That's going to be digital modulation. This is a form where you convert the digital signal to analog. You convert your digital signal to analog. Sometimes you might have your digital signal you wish to convert back into analog. For an example, like this. Your mobile phone uses digital signal, but then you have to transmit this mobile phone nikiti in a data, or else me mobile phone nikiti in a signal like using 4G connection you have to transmit. Using 4G connection you have to transmit in it. So this 4G connection tower rekavilla, it's analog, but your mobile phone generates digital. So digital to analog you have to transmit. We call it as digital amplitude shifting key, phase swing shifting key, okay, and phase shifting key. Now in here you can find it in especially in ECG machine amplitude. Amplitude digger, you increase it. They have the digital signal, okay, but you increase the amplitude in it like this. Okay, you have the digital signal and then you change the amplitude whenever there is zero or there is one. Sorry, whenever there is one, you increase it. So one high voltage one, this is low voltage zero. This is amplitude. You change the alteration of frequency, okay, and that is called as a frequency shifting key. The same signal sprint, whenever you have a zero it alters the frequency puluvantarang, okay, compress karna, trying to send it more, like increasing the speed. So whenever you have a zero there will be a relax like this. Then you do have phase shifting key. Phase is where you do the alteration in the signal. So whenever there is an alteration, you have the phase shifting key in here. So whenever there is 1 to 0, when it changes from 1 to 0 or 0 to 1, the phase also changes. When you shift from 1 to 0, the phase changes. ಮೆನ್ನುಮೆಯೋಗಿ ಮಾರು. See, methaning, it does the change. Methaning, it does the change. So exam what you have to remember? Exam you have to remember the style HRI. කොහොමද මේක මාරු වෙන්නේ කියලා HRI you all have to remember, nothing else. ඒ style එක විතරක් ඔයගොල්ලෝ මතක තියාගත්තත් ඇති. Where one is like this and this is 0. So that's under the digital modulation sections too. So with that, we will be going towards on encoding from our next week. Up encoding section nekai eta passe transmission podi podi pastikai tienne. We will be able to finish it soon. That comes to the end of our classroom for today. So in general, we learned about analog and digital today. We learned about the signal properties. We learned about the modulation. We learned on analog modulation. We learned on digital modulations too. That comes to the end of our session. This session recording will be also available in YouTube. Take care. Assalamu alaikum and have a nice day to all of y'all.